what is the role of endothelium in smooth muscle cell regulation generally, whether they contract or dilatate? So first of all, just to stress it, dilatation is when the muscles, smooth muscles in the walls of the vessels are relaxing. Contraction is when they contract. Constriction is when they contract. So we see that we have the endothelium, then we have the muscles, and then we have the serosa. What is critical? The endothelial cells, so those are that are in the very inside, so those that have the immediate contact with the blood, has very important role in the regulation of the microcirculation. So what they can do? There are generally two things that they can do with these smooth muscle cells, because muscle cells generally have only two things to do: contract or relax. Yes. So how the endothelial cells regulate relaxing? So they would regulate relaxing by production of the nitric oxide and prostacyclin. Those substances will lead to dilatation. Yes. What else? Why does the endothelial cells would produce the prostacyclin nitric oxide? There are a couple of things that will lead to it. I will make it clear. So shear stress. So stress, the force that is acting on the endothelial cells from the blood pressure. If it's increased, the endothelial cells would produce this prostacyclin nitric oxide. So generally, if you imagine that the pressure would increase, the blood vessels would be forced, would be pushed by this blood pressure. So as a mechanism to reduce this pressure, they may dilatate. Yes, so they may go a bit in this direction. Yes, be bigger, so that when the lumen of the vessel gets bigger, the blood pressure drops. And when the blood pressure drops, the endothelial cells may be, let's say, happy because less force is put on them. We have the histamine, acetylcholine, bradykinin, ATP. So of course, the endothelial cells are not working only on their own. Yes, they are regulated by the local and systemic factors like some hormones, both released locally and systemically. So histamine, acetylcholine, bradykinin, ATP, they're all connected, for example, with the inflammation. Yes. So in case of the inflammation, we also see, for example, that when some part of our body is inflamed, it's red. Why it's red? Because it's increased blood flow through this area. How the blood flow is increased? Through dilatation of the blood vessels in this area. How it is achieved? For example, by the endothelial cell, by producing the prostacyclin and nitric oxide from the because of the histamine, bradykinin, and other things that are in the inflammatory soup. Okay, but is there other thing that the endothelial cells can do? Yes. There is also the endothelium. So endothelium is causing the constriction. So one more time. So endothelial cells can lead to dilatation and can lead to constriction. When they would lead to constriction, for example, when they would lead to constriction, when they would produce the endothelium. And when they would produce the endothelium, when we have, for example, the pulmonary hypertension or vessel injury. So let's imagine that we have this vessel injury. Why we would want to constrict the vessel? Yes, why? Well, the answer is extremely simple. Because when we would constrict the vessel here, the blood flow would be severely reduced. Yes, so not so much blood would get out of the vessel, and we would stop bleeding, or at least limit bleeding. Yes, so it's very good that when we have the vessel injury, we have the endothelium production that leads to constriction. Yes, In case of the pulmonary hypertension, it's a bit more complicated. We will not delve into details. You just need to know that it is so. But we have also one more thing that is important. We have the ACE, yes, acetylcholinesterase. Angiotensin converting enzyme. Yes, this is similar words, but we have the angiotensin converting enzyme. What does the angiotensin converting enzyme does? The angiotensin converting enzyme is enzymatically changing angiotensin 1 into angiotensin 2. Both angiotensin 1 and angiotensin 2 are some hormones that are controlling the smooth muscle cells of the vessels. They are contracting that. So angiotensin 2 especially is constricting the blood vessels. So it increases the blood pressure. Angiotensin 1 has limited role. Yes, it's not very active. Angiotensin 2 is very active. So endothelial cells, especially in the lungs, have this role that they have the angiotensin converting enzyme that are able to activate angiotensin 1 to angiotensin 2, so they would cause the constriction of the vessels and increasing blood pressure, for example. Okay, thank you very much.